Let's do problem 1 of these math practice problems. I find when I go through these problems that it's very, very helpful to me, and I've been doing this a long time, is to make a little diagram based on this little story problem that's presented in the problem. Okay, so we're told that we have a box and that we're going to take it 1.5 meters straight up in the air, and we're going to exert 200 newtons of force to do that, and we're going to do that for 1.5 seconds. So 1.5 seconds. So also what I like to do is I like to write a little what I know about this problem. So I know that, okay, what do I know is I'm being asked for power. And so power is work divided by time. I know that from the reading assignment. I also know from the reading assignment that work is force. Whoops, let me get rid of that one. It's not divided by, it's times distance. The distance moved. Okay, so now what was I given? What information was I given in this problem? I told, in this case, the force is going to be 200 newtons. The distance, which I'm going to use D, is going to be 1.5 meters. And the time is going to be 1.5 seconds. Now, you may be thinking, it's asking me for power. How do I find power? Well, the first thing you have to do is, well, let's see, what do you need to know to find power? Okay, so you need to know work and you need to know time. You say, well, I'm told time is 1.5 seconds. No problem there. But I'm not told how much work was done. So you may think, oh, well, what do I do now? Well, is there enough information to find out how much work you did raising the box? And so the idea is, well, if you're told the force and you're told the distance through which you exerted that force, hey, you pushed this box up 1.5 meters, then you can calculate the work. So really, I can take this, which is work, and I can put it in for right there. So let's solve the problem, because now I see how to do this. Power is the amount of work you do divided by the time it took. But look here, in this green, work is force times distance. And now bring this over divided by time. So what I need to do then is I need to plug in my values, my force and my distance and my time, break out my calculator, and then I have the answer. So here we go. Let's see, what's the force? The force is 200 newtons. And then I'm going to multiply that by the distance moved. Well, I don't think I need a calculator. 1.5 meters. Then I'm going to divide that by the time, which is 1.5 seconds. Okay. So I see that I've got 1.5 on the top and I've got a 1.5 on the bottom. So those, we say cancel, because 1.5 divided by 1.5 is 1. So all that is equal to just 1. So now I have 200 newtons. Okay, this is a little confusing because the units didn't cancel, the numbers cancel. So I got a newton meter on top divided by a second. Okay, what is a newton meter? A newton meter is a joule. So this is going to be the same thing as 200 joules. A newton meter, is a joule. And then we divide that by seconds. And it turns out that a joule per second has been defined as a watt. And you may have heard about watts, like a 100 watt light bulb, or some kind of motors can be watts, or if you have a hair dryer, look at it. It's going to tell you how many watts it is. So that's a unit of power. So it's 200 watts. Hey, what happened? 200 watts. All right, let's look at the second problem. You lift a book from the floor to a bookshelf 1 meter above. So you're going 1 meter above, and you push with 15 newtons of force. That's like 4 pounds. And it takes you 2 seconds to do that, so you're in no rush. So let me get rid of this arrow here. All right, so I made my little sketch because I always think that's helpful. Then I like to write what I know. Okay, so I'm being asked how much power. And power equals work divided by time. And I'm not told, this is basically just like the other problem. So I've got work is force times distance. And what I know is F equals 15 newtons, distance equals 1 meter, and the time is 2 seconds. So we're going to do this just like the previous problem, which is that if power equals work divided by time, and work is a force times the distance you push through with that force, then we're going to take this and we're going to plug it in there. So here we go. Let's go ahead and just put the numbers in. Power, well, let's do this. Force times distance divided by time. So let's plug in our force. Our force is 15 newtons. Our distance, I'm not going to worry about the decimal places. I like to use parentheses because it starts getting kind of confusing about what's what there. And then the time is 2 seconds. So let's focus on the numbers here, right? I mean, so we can see what goes in our calculator or what we use in our head. There's 15 times 1, and we're going to divide that by 2. Well, either in your head or with a calculator, that's going to be 7.5. And again, we have these Newton time a meter, and then divided, that's watts, okay? So just know it's watts. So there you go. There's the second one, 7.5 watts. Problem 3. Again, another, what's the power? How much power what is your power output if you take a suitcase and you pull with 10 newtons of force, and now, wait, where's the distance moved? Where's the time? So distance we're not given, time we're not given. So, well, let's see. Well, maybe we'll figure this out. But things I know that power is work divided by time. And I know that work is force times distance. And I'm told that the force here is 10 newtons. But I'm not told distance and time like in the other problems, but I'm told velocity is 0.5 meters per second. Now, what can we do with this? And here's a good time to look at the hint. Whoops, that's not what I want to do. I don't want to do that. I want to, okay, well, I'm not going to, let's do it this way. Consider the hint. I can't draw and it'll start to move. And the hint is, basically, how far does this thing go in 1 second? So let's make t equal to 1 second. Then what is the distance that this suitcase goes in 1 second if it's going half a meter per second? Think about that. It's going 1/2 a meter per second. It's going to go half a meter in 1 second. So thank you, hint. That is going to be how I'm going to approach this. So now I know time. Now, we're not saying that, oh, it only went for 1 second, but every second it goes half a meter. So let's do it. Power equals work divided by time, which we've done this process a couple times already. Since work is force times distance, I'm going to replace this work with force times distance over time. So now, they tried to trick us, but we figured it out. So the force is 10 newtons. I put it in parentheses because I want to know the N is for newtons, and this X, it's not X, it's times symbol, times half a meter. I like to put stuff in parentheses when I got units because it makes the math, I think, a little less confusing. And our time was going to be 1 second. So now we take, what is 10 times 0.5? That's going to be 5 Newton meters. And divided by 1 second is, 5 divided by 1 is 5. So seconds. So all these crazy units here is a watt, okay? Joules per second. So that's going to be 5 joules per second or 5 watts. And we use capital W to abbreviate it. Okay, those are the 3 math practice problems.